Good morning, everybody. All right, here's our first lesson section of Chapter 1, Statistical and Critical Thinking. What we're going to do in this course is we're going to discuss different ways of doing statistical research as well as statistical analysis. And all this involves planning of how we're going to get our data. Once we get our data, how do we analyze it? And once we analyze it, how do we form a conclusion about it and present it to everybody else? All right, so the objective of a study, of any type of study, is to use a statistical method to attain sample data, or if you want to, data of whatever sample you're looking at, to make a logical, and I'm going to put that in quotes, conclusion of a population. So basically what we're doing here is we're gonna study a small group that's called a sample, and we're going to try to take this information and predict what's going to happen with respect to the population. So what happens between here and here is what this course is about. So we're going to our objectives. We're going to discuss how to get sample data, discuss different sampling methods, we're going to discuss the difference between statistical significance and practical significance. We're going to discuss voluntary response samples, statistical conclusions, based on the data, from the sample, No, the graphing is later on. Okay, so these are pretty much our objectives here. So a statistical study, which or you call a research, which we'll discuss, will be two different types. There's either an experiment or an observational study. So, and all this stuff boils down to a either this or this type, and that's what we're going to talk about in this first chapter. So when we do this statistical study, we're going to look at the three main parts of it. The preparation for the study, the analysis of the data, and the conclusion. And then we're going to expand what happens in each one of those areas. But before we move on a little bit further in there, a lot of people get these two terms mixed up. Statistics versus probability. Statistics is analysis of past events. Like you always hear in TV shows, so I have to be a statistic before you do anything. In other words, I have to die or something before you do anything. And that's what it means. So the death rate of cities, that's a statistic. Probability is an estimation of future events. For example, gambling. Actually, we see this before every sporting event, like on Sundays when we have professional football. What the commentators always talk about is, well, according to the records between these two teams, this team has to say 30% chance of beating this one or 70% chance. So again, they're taking guesses to the future based on past events. All right, so those are the differences of the two. This is a statistic course. We're going to look at and analyze data. You get data from events that happened in the past. And here's an example. This is when I showed my class. This is an example of the book. What does 78% mean in this case? 78% is the percentage of female veterinarian students who are women. This is according to the Herald in Glasgow, Scotland. Even though, I mean, this is a humorous example, whenever you make any statement that uses numbers, a percent or a ratio, a comparison, always state the source where it came from, because it has to be verified before you can use it. The funny thing about this is the percentage of female veterinarian students who are women. I would kind of hope that all female students are women. All right, so that was one humorous thing I thought. All right, so let's begin. Let's look at some basic definitions. Of basic terms that we're going to use. Because mathematics is a symbolic language that associates numbers and operations and symbols to actual operations. So if I say plus or difference, all this stuff, once I say the word, then you know what mathematical process has to be taken to accomplish that. So when I use the word data, what I'm talking about here, first off, data is plural. What it means, it's the collection of observations or measurements like gender, age, or gender, hair color, or survey responses. Data can be numerical, or it could be, which is called quantitative, or it could be categorical, which is qualitative. Quantitative is numeric numbers you can do calculations with. You can add, subtract, multiply, divide. Qualitative are observations that we have to take the observations and somehow quantify them so we can analyze it. For example, grades. Grade A, grade B, grade C, D, and F. Well, we can't do math with that. A plus C does not equal AC. So what we do to determine grade point averages, we say an A equals 4 points, B equals 3 points, C equals 2, D equals 1, and 0. So now we can compare the numbers and use those in some sort of analysis. So remember, data is plural. The singular is datum, which is singular. All right, so whenever we say data, we're talking about a group, more than one piece of value, observations, or numbers. Let's define what statistics is. Statistics is the science of planning, studies, and experiments obtaining, that's one, obtaining data, 3, organizing the data, 4, summarizing the data, 5, presenting the data, 6. Actually, I got this out of order. interpreting the data and analyzing the data. And all this to arrive at a logical conclusion. So what we're expecting here, I'm describing here, is a study of some sort, a research experiment. You always start off with an observation, but you have to notice something's wrong. Then you have a hypothesis, which has a hypothesis is a logical guess. I say what you have here is a research question, because once you observe something, you say, okay, now what causes that? And then from there, you have to set up the study, which is all this stuff. Okay, so let me see. It goes planning, obtaining the data, organizing the data, analyzing the data, interpreting the data, summarizing the data, and presenting the data. That's the order it should be. So that's what statistics is all about. All right, the next term we're going to discuss is the population. Focus, focus, focus. There. The population is the complete collection of all measurements or data that are being considered. It's a complete collection of all measurements. In other words, the population is the total number of data collected. That's in statistics. In the real world, a population is 100% of whatever you're looking for. Whatever you're examining. So it's the population is 100% of it. For example, the population of the United States, or the population of the world is around 7 billion people. But if we were to do a study, we couldn't survey or observe 7 billion people. So what we do is we look at a sample. a subset of the population that best represents the characteristics of the population. So if we're looking at this, we see numbers in the statistical analysis. When you see a capital N, that represents the population. If you see a small n, that's the sample size. So the population of Mountain View is something like 16,000. The sample size of our class is 25. So we're looking at if I'm going to study the students at Mountain View, I could survey the students in my class. Again, it's not going to be accurate because the larger accuracy comes from a large sample size. In other words, the closer little n, which is the sample size, gets to capital N, the population, the more accurate the results of the study will be. Okay, and pretty much that goes in a rule called the law of large numbers. If I was to roll a die 5 times or 6 times, there are 6 sides on a die. So I can get, if I'm lucky, I get one of each type. But that probably won't happen. So I'll get a smattering of different numbers, 1 through 6. But is that showing me that each number has the same chance of being chosen or rolled when I roll a die? No. So what I have to do, I have to keep on rolling. The more times I roll it, the more spread out, more even each of the graphs will be for each of the numbers. And it'll show me that each number is the same possibility of being chosen. So that's the law of large numbers. So the population, the census is an analysis or the collection of every member of the population. The collection of data from every subject in the population. Whenever in statistics, we use the word subject to represent people. a sample unit is anything else. All right. So also the census, in lecture I was talking about an example that we in biblical times, they were talking about when Jesus was born. King Herod wanted to have wanted to have a census, so everybody had to go to the city of their birth. And since Joseph was born in Bethlehem, that's where they had to go to be counted. So that's where you see a story about when they hear census. That's what it does, is it's counting the entire populace to see how many men, women, children there are in the kingdom. The United States does it once every 10 years. And it's done once every 10 years because it's very tedious and very expensive, because they have to hire a whole bunch of people to come and help with the collection of the data. Yeah, let's take an example. In the journal article, Residential Carbon Monoxide Detector Failure Rates in the United States by Ryan and Arnold, American Journal of Public Health, Volume 101. Remember, whenever you make any type of statistical discussions or bring about any facts, you have to state the source. It was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide the alarm of hazardous carbon monoxide conditions. So in this case, what number represents the population? Remember, by definition, population is all of them, the total. So what we have here is 38 million carbon monoxide detectors. Now, a subset of those, the sample, when 30 of them were randomly selected, the sample was 30. And the statistic, we would go a little bit further. Out of these, 12 out of 38 million are defective. Or you can say that 12 out of 30 are defective. So that would be the statistic. But in this case, that's what we're looking at. Okay, let's look at the process of a statistical study. Developing a statistical study. And those are the three parts. And fortunately for us, because nowadays we have computers and calculators do the work for us. Imagine the old days. They had, 90 years ago, 50 years ago, they didn't have computers. They did it all by hand. So first step, our preparation. Preparation. We have to look at something called the context of the data. In other words, we're looking at the context data is what type of data? What are you going to collect? Will you collect? Because remember, it has to, when you're preparing a statistical study, that means you had the first part done already. You had your observation, you noticed something, and you had your research question, your hypothesis. So now to find the solution to that hypothesis, what kind of data do you need to collect to answer your question? Right. So in the example we use here in the first chapter of the book, the first section of the book, the data is we will examine the death rate of manatees in Florida and the number of boats in Florida waters. Basically, what we're looking for here, that's basically as I is there a relationship between the number of boats and the number of manatee deaths? That's what we're looking for. So our hypothesis would be something like as the number of boats increase, the number of manatee deaths will also rise or increase. So the book gives us a data set. It looks something like this. Number of pleasure boats and 10,000s. Manatee deaths. So we have 99, 99, 97, 95, 90, 90, 87, 90, and 90. So 92, 73, 90, 97, 83, 88, 81, 73, 68. All right, so what does this mean? Said these are the different types of pleasure boats. It could be like jet skis, motorboats, sailboats, types of that. These are the different types. So in this year that they looked at, the number of boats they have, so this is 10,000. So this is 900 or 990,000 boats. This is 990, and so forth. So out of those, we had 92 deaths using with this pleasure boat. And there's another pleasure boat, different type. So then we have to look at source of the data. Where did it come from? Because if the source of the data isn't reputable, if it's just somebody making up numbers, then you can't waste your time with it. But for this thing, this data is from the Florida Department of Highway Safety and Motor Vehicles. So that's for the boats. And the Florida Marine Research Institute. So our data, this data is from the Department of Motor Vehicles. This data is from the Florida Marine Research Institute. So we know the data here is pretty accurate. So that's the first thing I have to look at. Now, since we have our research question, our hypothesis, we have our data, it's valid. What we have to look at here is discuss how is the data gathered. In other words, sampling methods are how the data is collected. Because yeah, you have to make sure that the source is valid, but also the way the data is collected is also has to be valid. We have to look at, is it random? Randomization. Is it random? Or was the data specifically observed by one person or group of people in a specific place? Or was it throughout all these places? You have to know where the data came from, what it's all about. You must have sound and reasonable sampling methods to assure the data is valid. If the data is valid, and the conclusion will be also valid. So what that means is if you collect the data incorrectly, I don't care what you do with the numbers, it's going to be wasted for you. All right, so pretty much here's the basic rundown of what we're looking at here. Prepare your study. The context, what's the data going to represent? What's the goal of the study? Where's the data coming from? What sampling method you're going to do? Then once you do all that, get all that, this is the most important. The more time you spend here, the less chance of errors you have down there to the rest of the thing. You collect the data, analyze data. How? You're going to graph it. You're going to explore the data using different types of statistical analysis and observations. You're going to analyze the numbers to see what happens. And then we're going to statistically analyze the numbers. We're going to graphically explore it. We're going to statistically explore the numbers to see what it looks like. Once we do all that stuff, now we could determine whether it's a practical or statistical significance. And our conclusion, once we finish, then we could go ahead and publish our findings based on what we've done and what we've collected. When you have, okay, that's to the example of the manatees, but a lot of people are surveyed in like malls and stuff in stores, like it's at Sam's and Costco. You have these people who have free samples of food. You go in there and test them out. So let's look at this. The first one that we're going to define here is a voluntary response sample, also known as the self-selected sample. This one is when the subject decides to be included. In other words, if you're in the mall and you see somebody, hey, if you take this survey, I'll give you this coupon for free ice cream. So in other words, they're bribing you for your answers, which we'll see in the long run. This type of stuff you don't want to do. And you definitely see this on internets. You have these things online say, hey, take this survey if you're interested in this. All right, so these type voluntary response samples, it's not that accurate. Try to keep away from it if you can, because if you think about it, who usually does surveys, like customer satisfaction surveys? The people who are upset with the service. People who are happy have nothing to do. So once they get what they're happy with, they just hang up. So people who are gripey will be the ones, so that automatically skews or influences the whole study. Let's look at an example here. Voluntary response sample. ABC television show Nightline asks viewers to call with their opinion about whether the United Nations headquarters should remain in the United States. Viewers then decide themselves voluntary response, whether to call in with their opinions. 67% of the 186,000 respondents said that the UN should be moved out of the United States. In a separate and independent survey, 500 respondents were randomly selected and surveyed, and 38% of the group wanted the United States to move out. It's a big change. The two polls produced dramatically different results. Even though the night poll had 186,000, the other one had only 500 randomly selected. But the 500 randomly selected are going to be more accurate because these 186,000 people who responded to this TV show, they have a gripe about it. They have very strong feelings about it, one way or the other. And usually people who have gripes, okay, 67%, they want the US out of it, or the UN out of the United States. So if you just do 500 people, say, okay, here's a situation. What do you think about the UN being in New York? Is that good, or should I say? So it's more accurate. Even though the sample size is small, it's a better representation of what's going on. All right, now let's look at, okay, we've determined our study. We've collected our data, our sample size, we've collected our data. Now we're going to look at how we analyze the data. How can we analyze the data? What do you do first? So one way we can do it is by graphing and exploring the graphs. What you're looking for is, now, it's a picture's worth 1,000 words. This is very true, because if you just look at a whole bunch of data, all you'll see is a sheet full of numbers, which means absolutely nothing. If you take that data and put it in some organized form, in some graph, and we'll also cover that in this chapter on different types of graphing techniques. What you can see is how so we had a bar chart. You can see how the data is spread out. And there's other type of analysis. So that way we can see what does everybody think, or where it leans towards. So that's the first way. Before you do anything, draw a graph, because it's much faster that way. The next way is by using various statistical methods. The statistical methods we're talking about, okay, these are not impossibly difficult. We do it all the time anyway. Like, for example, if you want to know what your grade is, if your grade is based on an average of your tests, you could tell me what your grade is by adding up all your test grades and dividing by how many tests you have. There's your average. And that's one of the statistical methods. So the stuff we're going to cover in this course, it's not going to be that mind-altering difficult. The problem is going to be we have a lot of data, and so how do we make it easier for us? So yeah, so we graph it first, and then the next thing we do, we run it through some statistical methods or statistical calculations. And then we see how the data behaves. So then we go to our conclusion. After you do everything's finished, we come up with a conclusion. Was my hypothesis correct or was it not correct? Determine whether your hypothesis was correct or not. And it's interesting how this course is set up. The last thing you do is determine if the hypothesis is correct or not. That's the last thing we're going to do in this class is do hypothesis testing. We're going to learn how to mathematically calculate the solution, the results, and see if our hypothesis is correct or not. We're here, also here at this point here, we're going to look at does all this stuff have a statistical significance or practical significance? Statistical significance is when you get a result that is unlikely to occur by chance. It's less. Sorry, so what we're going to do also in this course, we're looking at the chance of something happening. Of it happening is about 5%. And this percent will be very important later on in this book. So we're looking here is to be statistically significant, we get a result that's unlikely to occur by chance. I mean, something was making it happen. In other words, we're saying the chance for it to really happen is about 5%, which means there's a 95% chance that it will not happen. That's the statistical significance. Practical significance are when you have findings when your finding does not make enough of a difference to justify it to be practical. So if there's a unlikely chance of it happening, then we have statistical significance. If your finding doesn't make enough of a difference to justify, is it a practical solution? Because one thing here in this class is you have to be able to look at the answer and determine, is it a justifiable, is it right, is it wrong, is it overstretching the bounds, or what? So When your findings does not make enough of a difference to justify it as to being practical. So is your solution practical or not? Possible or practical? So that's what we're looking at here. All right, let's look at an example. Statistical significance versus practical significance. Pro-care industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender they desired. In the absence of any evidence of its effectiveness, the product was banned by the Food and Drug Administration, the FDA, as a gross deception of the customer. But suppose that the product was tested with 10,000 couples who wanted to have a baby girl, and the results consisted of 5,200 baby girls born in 10,000 births. So remember, we had 10,000 couples. This result is statistically significant because the likelihood of it happening due to chance is only about 0.03 cents. So chance doesn't seem like a feasible explanation of this happening. 5,200 out of 10,000. That 52% rate of girls is statistically significant, but it lacks practical significance because 52% is only slightly above the 50%. Because if you didn't use the drugs, you have a 50-50 chance. So it's statistically significant, but it's not practically significant. Practically significant would be if something was like, if it was an 87% chance or 90% chance. If not a chance, but if the results were 90% success. So for practical significance, you have to look at the end result, see what happens. The statistical significance, we have to see what is the probability of it happening mathematically. All right. Now we have to look, how do we analyze the data? Potential pitfalls. What that means is, what are the possible problems that you can get? The first big problem you can get is what we call misleading conclusions. So whenever you do a statistical analysis, you should make sure that everything and everyone understands the statistics, and you have that the audience that you're dealing with understands what you mean by when you say standard deviation when you talk this. So you have to first make that clear. This way, because if your audience does not understand the terms or procedures used, then The conclusion can be invalid and the audience wouldn't know. Basically, what that means is you could baffle them. If you want to confuse somebody, use a lot of technical jargon. So, and that's typically, as a rule of thumb, if somebody you're talking to is trying to sell you something and they just use a bunch of technical words and phrases and examples, then they're trying to hide something. If they're trying to be honest with you, they'll break it down to the stuff that you'll understand. In our example about the manatees. So here's, remember our manatee example. The more boats that were out there, the more manatees were killed. Can you say that if there are more boats, then more manatees are going to die? Is there a number that once they reach so many number of boats that nobody could motorboat anywhere? So we're looking at the example that was stated in our manatees. Is it something called a correlation? Towards more boats equals more deaths. So are the deaths caused because of more boats? You can't say that, because it could be now because the food source is running out. Not because of the boats, because we have more fishermen and more swimmers scaring the fish away, or whatever the manatees eat. There's a rule of thumb that says correlation does not imply causation. Just because two events may be related, it doesn't mean it's the cause. So correlation does not imply causation. Another is sample data reported instead of measured. What this is saying is, when you're dealing with data in a study, an experiment, collect the data yourself instead of outsourcing it. Because now, if you do it yourself, then you know it's legit. But if you outsource it, you don't know if, well, they're getting tired and just made up some numbers just so you can go home early, or what. You lose all control over it. The example you used in the book. If if you're interested in seeing what the average weight of people are, you could weigh them yourself and record it, or you could ask them yourself and hope they give you the right answer. So collect the data yourself. So sample data reported instead of measured. So somebody gave you the number, here's your data. You ask somebody, what's your weight? That's reported, as opposed to you measuring it. That's another pitfall. That's number 2. Number 3, the questions. This next one deals with 2 of them, actually. Loaded questions. That means it's the wording. Because the way you word a question can influence how people respond. For example, within the book is, here's example 1. Should the president have the line item veto to eliminate waste? Or should the president have the line item veto or not? You see how the first one, you're trying to influence to eliminate waste. The other one says, well, just in general, should they have the line item veto or not? Line item veto is a bill when it goes to the president. It passes the House and Senate. It can have, let's say they call it the education bill. That's what they title it. But inside there are a whole bunch of other bills that are being passed along with it. One could be on taxes, would be on salary increases for congressmen. So what the president has a chance to do, instead of rejecting the whole bill, he can go in there and say, no, I don't want that one. I don't want that one. I'll keep these. That's what the line item veto is all about. So the way it goes, the example here in the book said, should the line item eliminate it? Just because they put it in there, they said 97% said yes, as opposed to 57% said yes to the second one that didn't have a factor in it. So the way you word the questions, you can load the question to influence the people to vote how you want them to vote, which is, again, this is the fallacy, the problem we have with statistics. The other one with the questions is the order of questions. The order of items in questions or the order of the question itself. may affect the outcome of the survey. Here are the examples here. Would you say that traffic contributes more or less to air pollution than industry? Okay, or another way you can write it. Would you say that industry contributes more or less to air pollution than traffic? Would you say traffic contributes more or less to air pollution than industry, or would you say that industry contributes more or less than traffic? So what this one says, 45% blame it on traffic, 27% on industry. On this example, 24% said that traffic and 57% on industry. You notice whatever's bigger comes first in the question. So by the order of how you put things in the question, you've pretty much influenced on how they're going to respond. All right, the fourth one. Non-responses. When someone refuses or forgets to respond to a survey question. For example, they may refuse because it's too personal. For have you ever been arrested for drunk driving? Or do you still beat your children? Whatever the example could be. So somebody could refuse to put it in there because they're embarrassed or it's irrelevant. They just don't put it in there. So non-responses, just by not having any response for one or multiple questions in a survey, you've just pretty much changed the course of it, because now instead of having 100 people, you now only have 99. So it affects it slowly. And the last thing I want to talk about are percentages. And how to convert. First rule. Okay, what is percent? equals, when you say per, it's divided. Cent is 100. So a percent is actually 1 over 100. All right. In percentages, you could only go between 0 and 100%. You can't have less than 0. You cannot have more than 100%. Percent is equal to part over total times 100. And that's going to give you your percent. Let's look at some calculations or conversions. Whenever you read in a question percent or percentage of, what that really means is multiplication. So like 6% of 10. What you have to do first is, and this we'll talk about in a little bit, we have to convert our percent to decimals. So it's 0.06. The word of becomes multiplication, 10. So it equals 0.6. Okay, or 10% of 750 equals 75. So let's look how we convert things. We're going from decimal to percent. So if I had 0.25, that's the same as 25%. Multiply decimal number by 100 and place a percent sign after the solution. So basically, it actually means when you can go from decimal to percent, move decimal 2 spaces to the right. No matter where the decimal is, move it 2 to the right and place the percent symbol. So if I had 0.031, I move decimal 1, 2, so it's 3.1%. Right. Let's go from percent to decimal. This one is, so first off, the percent symbol. Move the decimal 2 spaces left. So we had 25%. This is actually 25.0% because after every other number, if there's no decimals, it's automatically 0.0. So I drop this percent, move it 2 to the left. The answer is 0.25. Another way you can look at it is, remember, the percent is equal to 1 over 100. So 25% is the same thing as 25 times 1 over 100. This tells me I'm moving my decimal 2 to the left. Since I have 2 zeros on the bottom, that means 2 decimal places. What this one means is when I'm going from decimal to percent, I'm multiplying by 100. Because if you multiply by 100, because there are 2 zeros there, I'm multiplying it, so I'm going to make it bigger. So from decimal to percent, you move to the right 2 spaces. From percent to decimal, move left 2 spaces. And last one is fractions to percent. First step. Divide the numerator by the denominator. That equals some decimal. Because remember, when we're dealing with percent, well, in these kind of questions, you can have more, but typically it's the smaller number on top and larger number on the bottom. That's going to give you some decimal. But it can also be that you have the larger number on top and the smaller on the bottom, which now what that means is you'll have a number like this. But the process is still the same. Once you get a decimal, if I'm going from a decimal to percent, I got to multiply by 100. So I move it 2 spaces. Same thing here. There's this one. And then I have those 2 spaces and put a decimal or a percent symbol. So easy one to see. 3 over 4. 3 divided by 4 is 0.75. Move it 2 spaces to the right is 75%. Right. So that does it there. Good luck, everybody.